This Explain It is going to be about how to perform gas stoichiometry. Avogadro's law allows us to compare volumes in an equation. So just as there's a mole ratio, there's also a volume ratio. So for instance, in this water equation, we learned that the coefficients gave us the moles of each reactant and product. So we would say there were 2 moles of hydrogen, 1 mole of oxygen, and 2 moles of H2O. Well, when we're speaking about volumes, the relationship is the same. So we have 2 volumes of H2, 1 volume of O2, and 2 volumes of H2O. And so in this way, we will have the ability to relate and convert liters to liters. Because basically we could say that we have 2 liters of this, 1 liter of this, and 2 liters of this. And so it's called the volume ratio when we're comparing 2 substances, but often I'll say it's the liter ratio. I'm going to do the example on page 382. So I'm going to pause here for a second while you open your books to page 382. All right, so when we're doing this stoichiometry, we always know the first step is you have to have a balanced equation. So the balanced equation is C3H8 plus 5O2 yields 3CO2 plus 4H2O. Next step in stoichiometry is to write down the given. So when looking through the problem, it says, what will be the volume in liters of oxygen required for the complete combustion of 0.350 liters of propane? So the given here is 0.350 liters. And the question is, what volume in liters of oxygen is required? So we need to figure this out in liters. So just as I showed you in the previous slide, liters to liters is the same as going moles to moles. We're going to use the liter ratio instead of calling it the mole ratio, which is a ratio of the coefficients. So we're going to work our problem just as we always have by writing down the given, 0.350 liters of propane. And we're going to convert that to liters of O2. And so we need the liter ratio. On top, you always put where you're going, so we need 5 liters O2. And on the bottom, where you came from, we have 1 liter C3H8. And so we will observe that the liters of C3H8 will cancel out. And now we just have to multiply 5 times 0.350. And we end up with 1.75. In the second part of the question, it asks for liters of CO2. Well, this is again a liter to liter ratio. We can use the same given. So we're going to start with 0.350 liters C3H8. And we are going to convert that into liters CO2. Again, we're going to use volume ratio. I often refer to it as the liter ratio. Same thing. Where you're going goes on top. 3 liters of CO2 goes on top. Where you came from, 1 liter C3H8 goes on the bottom. So therefore, our liters of C3H8 will cancel out. And so we need to take 3 times 0.350, and we get a number like 1.05. So to refresh, what you do is you write down the given, you multiply by the volume ratio, which is just like the mole ratio, and you convert it to liters of a new substance. Okay, together we're going to do number 1 on page 382. I would like everybody to write this down. All right, step 1, we need a balanced equation. This is a very familiar equation, the water equation, so go ahead and copy that down. Next, you're going to write down the given. So in this example, they give you 4.55 liters of oxygen. So we write that down, And next we look at what we need to go to. And the question says, what volume of hydrogen gas is needed to react with this? So the question is this, and we want it in volume, so that's going to be liters. Once you have this set up, you recognize that it's a liter to liter problem. So liters to liters is just like moles to moles. So you are going to multiply by the liter ratio. All right, so let's do that. We write the given down, 4.55 liters O2, and when we're done, we have to convert 2 liters of H2. All right, so we need the liter or the volume ratio. So on the bottom goes O2, liters of O2. On top is what you need. We need liters of H2. This is the liter ratio. We get the numbers from the coefficients in the problem. So we get a 2 from here. We get a 1 from here. 4.55 times 2 is 9.10. All right, so let's just refresh what we did. We wrote down the given, and we times it by the volume ratio, often called the liter ratio, which looks just like the mole ratio, to get our answer. All right, I'm going to pause this video, or you should pause this video, and go ahead and work this one by yourself. I gave you the skeleton equation, but you have to balance it before you go on. It's a liters to liters problem, and remember to use the liter ratio. All right, you should have got the answer as 0.313 liters of O2. If you did not get this, check with someone at your table. The next video is going to be about converting from moles to liters and liters to moles.